if you want to argue anti-reductionism, then what sort of strategies are available to you? Again, I'm not making a full list of that, but it's an interesting thing. The first thing one has to note is the following. If you are a reductionist, so you want to reduce the upper level to the lower level, it's fairly clear what you have to do. You've got to say what sort of reduction you intend to have. So you say, I want to have explanatory reduction. And then if someone says, okay, you claim that, so show me the reduction, then what you do is you show the reduction. You construct the reduction and you show how all these things at the upper level can indeed be explained or deduced or whatever what you are claiming. So what you have to do is fairly clear, right? You may say, well, I can't do it for technical reasons, it's too complicated, but this is why I think it's plausible and so on and so forth. So you know what you're doing and you know what the program is you have to fulfill. That is much, much more difficult for the anti-reductionist, because the anti-reductionist claims that no reduction is possible. So it's an impossibility claim. And if you ask yourself, how can I argue an impossibility claim? It would mean that you run through all single possibilities and show that they are not possible, right? So you can't really do that, right? So you don't really know how to argue an impossibility claim. You may have the feeling, oh, that reduction doesn't work. But the point is, when I ask you then, so what sort of strategy are you going to follow in order to convince others that a reduction is impossible? That's much harder. And it's not clear what sort of strategy you can use. So this is a problem that everyone who defends an anti-reductionist program has. In the formal sciences that works, because you can show then that a reduction, a possible reduction of the assumption that you can reduce leads to a contradiction. In the formal sciences this is possible, but it's not possible in the empirical sciences. And all those people trying to argue anti-reductionism have really that problem of the way to how to argue. And that's, of course, in a sense unfair, because they can be right. They simply can be right. And then the problem is they have much more problems to show that they are right than principal problems than the reductionists have. Okay, this is, by the way, just one sentence. I set up once a program about anti-reductionist arguments because I wanted to find out what are the possibilities that the anti-reductionists have in order to have a sort of toolbox for those who want to do some anti-reductionism. I never finished that project really, but that's a different story. So let's look at the anti-reductionist strategies, and Hoover uses some of them, but usually those people using these strategies have no, at least the scientists, also sometimes the philosophers, have no clarity about the problem that they're facing with, and they just intuitively bring something forward that looks like an argument against reduction, possible reduction, and usually it's a little fishy. So let's look what he is doing. So he thinks, as I said, Hoover believes in an autonomous and non-eliminable in principle macroeconomics. This is what he says in some of these papers. And he's got a variety of different arguments, and some of the arguments in some of the other papers, I think they are just really very bad. And so I tried to use this paper because that has, as far as I could see, the best arguments that Hoover has to offer. And sometimes the arguments for the in-principle ineliminability of macroeconomics are very hard to understand. If you really try to understand what is he saying really, where's the argument exactly, then I did have my problems, so I tried to do my best to reconstruct of that. Now, what one should note first of all is, if you look at the sciences, that in practice the question of the in-principle eliminability of some field is often irrelevant. So for instance, if you do solid-state physics, then the question, or chemistry or biology or sociology, and sociology is possibly the case that's most alive, but also biology, the question then of some macro level is in principle not reducible, or only in practice because it's much too complicated, is a question that's mostly uninteresting for scientists. When they know we can't do it, it's not the question whether they can't do it in principle or in practice. If they say, okay, we can't do it, then we don't do it and do something else. Very simple, right? So the question of the in-principle possibility is typically a sort of philosophical question, right? Sometimes interesting, sometimes not interesting. So this is, first of all, so I think in macroeconomics, I think the question whether in principle macroeconomics could be reduced without any rest to microeconomics is not a question, at least I cannot see that at the moment, that's really an interesting question. The point is some people try to reduce macroeconomics and then they are successful, moderately successful more or less. Other people say, oh, I don't believe in it, and then they do pure macroeconomics. And the question whether in principle it's reducible or not, it's not a question that's really of scientific relevance. It may be at certain points in scientific development, for instance in biology, or rather already in chemistry. That was in the 19th century, in the 1830s, there was the idea that organic matter is in principle different from anorganic matter. You know, this is why we still speak about organic chemistry and anorganic chemistry. And people believe that organic matter is in principle different from anorganic matter. And then I think in 1837 or something, a chemist showed that one organic substance, well, I don't know the English word, Harnsäure, anyway, that organic substance could be synthesized from anorganic components, which then showed, and this was an in-principle thing, so that was the argument that in principle it should be possible to reduce anorganic matter to organic matter. And that was, of course, a scientific question of high interest, but in many cases, these in-principle questions are not the questions that are really interesting for the scientists. The philosophers care about them, and sometimes usefully, sometimes less usefully. Philosophically, the question is interesting. For instance, and that's a question, I mean, that is now not being asked anymore, what is the nature of life? So in the 50s, people said, what is the nature of life? Is life something that is in principle reducible to chemistry and physics? Or is it not? Is life a phenomenon that is, sui generis in some very, very deep sense? Or is it not? Is it just, one form that a highly organized matter can get into? So that is, of course, a question of philosophical interest, really deep philosophical interest. But usually for the scientists themselves, these questions, or the question then in the 50s, this was 60s, this was still a discussion, are viruses alive or are they not alive? Nowadays, no serious biologist would ever say this is a meaningful question. I mean, it just depends what you think life is, and then a virus is either alive or it's not. So it's not an interesting question. Okay, so all right, so let's go now to the anti-reductionist strategies that Hoover is using. And the first strategy that he is using that is often fueled, it's a strategy that's often fueled by an apparent heterogeneity of the two domains. You look at the two domains and then you say, look, there is such a conceptual gap between the two. It's impossible to reduce that. Look, it's so different from that one. How can you ever understand what's going up here by the means you get from the lower level? And then that's, for instance, in biology, a very strong argument. And people say, one of the famous 20th century biologist, Ernst Mayr, used that argument. If you look at biological phenomena, what they're doing, how helpless is physics to explain that, what's going on, what makes biological sense, and so on. This is, for instance, phenomena of life are utterly different from the behavior of dead matter. Therefore, reduction of biology to physics and chemistry is impossible. That's an argument. It's not a good argument, I'll tell you in a second, but this is a typical argument that people use who are not really completely educated about the subtleties of that debate. They say, look at that domain, and look at that domain, that's impossible that you can build a bridge there. They're so utterly different. So, for instance, the argument that Hoover has in this context, macroeconomics is supposed to come up with causal regularities, and as he nicely says, billiard ball causality. This is how I showed you it, how in physics and in the 17th century, this concept of causality that we use today was really shaped. And he says, look, at the upper level, we want to come up with causal regularities of that billiard ball causality. However, on the micro level, intentionality plays a role. Look at the ambiguous footnote, but not now. And then you say, the intuition is then, how can it be that on the lower level, we have peoples with intentionalities and they do sometimes this and sometimes that. How can that, if you add it up, if you aggregate it, lead to billiard ball causality on the upper level? That can't be the case, right? This is impossible because you have a conceptual gap there. And then you say, yeah, that's right, that's impossible. Well, causality on the macro level can hardly be recaptured by the intentionalities on the micro level. This is how he argues. But that argument is really deeply fallacious. So if you look, for instance, in physics, if you look at thermal phenomena, coldness and warmth and, sunshine on your skin and you feel the warmth, and then you compare that with mechanical phenomena, with billiard balls, and you say, no, look, billiard balls, one clicking there and then. That has nothing to do with the phenomena of warmth. And no, this is just utterly different. Or you look at electricity and magnetism, right? Look at that you have electricity, you have things that repel each other, or magnetism, you have a magnet and that moves around. And then you say, oh, this is so utterly different from light. Light is a phenomenon with colors and that's nothing to do with electric phenomena and magnetic phenomena. Well, all false. Light is electromagnetism, and thermal phenomena are mechanical phenomena in the end. And that they feel so different, well, that can be easily explained. That depends on our sensual apparatus, on our perceptual apparatus. And we have perceptions, for light, which are different from the receptors for mechanical action. And therefore, we think it's completely different. But that's an artifact from our sensual apparatus, our perceptual apparatus. So we've got to be very careful when we judge phenomena that we perceive in one way or another, and then to say, oh, there's an unbridgeable gap between them. No, that may be an unbridgeable gap that's in us, right? So that's not a very good guide to use that. And so if you have the feeling there about this causality, this is very, very, very slippery. And the arguments very often lead astray. Well, in this context, there's an often occurring ambiguity relevant, where he says there is a conceptual chasm between the microeconomic analysis and the macroeconomic analysis. And that is the chasm that I said already. There is a difference between claiming that the reduction is in principle impossible or that it is exceedingly complex. Right? There is a deep difference between that. And even Nobel Prize winner in physics sometimes produce a mess there that they don't distinguish that. It's one thing to say, it's increasing, it's practically impossible, for instance, in physics, to build up, if you only use the micro level, namely atoms, and build up from there certain theories about solid-state physics. It's practically not possible. So you better use the other approach. You go from up there, and then you go down and try to make a contact. But one thing to say it's exceedingly complex, and the other it's impossible, in principle impossible. And Hoover there tends to say it's in principle impossible. But again, the question is how to get an argument for that. It's very hard to argue that something is in principle impossible, right? It's very difficult to argue it. And if it's your deep feeling, well, forget about your deep feeling and analyze it and say, yes, I don't know whether it's in principle impossible or not. So it seems to me that to argue the in principle impossibility of reduction of macroeconomics to microeconomics seems to be very tricky. I would love to see an argument if there is one. Okay. So the exceeding complexity is often obvious, but the in principle non-reducibly is mostly extremely hard to argue, and that's the same thing. So if you want to defend macroeconomics, then why don't you just do good macroeconomics without reduction and then show how good your results are, or you do reduction and leave it open, what's in principle possible or not. It's irrelevant for your practice anyway. Right? Unless you want to become a philosopher and engage there in discussions whose value I do not evaluate at the moment. Okay, so that's the first anti-reductionist strategy. Look at the difference between the levels, and then you may get the feeling they are so different that a reduction is impossible. But that's, as I said, in many cases in the history of science, it has been shown that it doesn't look too good. That is really badly misleading. I mean, the longest one was in the Aristotelian world picture. In the Aristotelian world picture, you know, the Earth in the center, and Aristotle thought that the sublunar, the moon was the first one outside of this earthly sphere, so to speak, and he thought that the Earth and everything on Earth is made of 4 elements, and then comes outside of the Earth comes then the moon and the planets and the sun and so on and so forth, and they are made of a different element, namely the 5th element, quintessentia, the ether. And that was deeply anti-reductionist, and the argument was the same. I mean, that you say, look, what's happened here on Earth, look at the motions that we see on Earth, they come to a rest, and everything changes, it's chaotic, and now look in the skies, and you see the circular motions in regularity, they never stop. So these regions are utterly different, you know, the matter is different, the laws or regularities are utterly different. Yes, it looks utterly different, but we found out then, 17th century, this is the big revolution, that say, no, it's basically the same as on Earth. It's just, you know, the combination of stuff and situation is such that we get there motions that are, well, longer lasting than the stuff we see on Earth. So don't get fooled. All right. Okay, so we come to the second anti-reductionist strategy. And that's a strategy you also find then in a more sophisticated way how to attack reductionism. What you say is the 2 levels in question cannot clearly be separated because the micro level cannot be described without elements for the macro level. So what you're saying is, look, your whole enterprise is wrong-headed. I'm not saying it's possible or not possible. I'm just saying it's wrong-headed because what you need for a reduction is a clear separation because of the levels. You're going to say, this is here the macro level, and that macro level I'm going to reduce in whichever sense to the micro level. And then, of course, one strategy is in order to attack that program is, look, you cannot make this distinction between the macro and the micro level. There is one economics anyway, right? So this is a strategy also used in different areas, for instance, chemistry to physics. People use it. Biology, I don't have an example in mind at the moment. But anyway, this is also a strategy well known. Let's see how good it is. In this case, the 2 levels are entangled such that a proper question of reduction of macro to micro cannot really be posed, right? This is, so to speak, you remove the foundation of the whole debate and say, look, it's an enterprise that doesn't make sense because you cannot, the levels, there are no levels really, they are entangled in such a way that you cannot ask this question. So Hoover uses that in a paper from 2008 on some pages. And here roughly the argument is the following, that he says that microeconomics depends on macroeconomics. It's not independent of it. So in order to set up microeconomics, you already have to use macroeconomics. And therefore it doesn't make sense later than to reduce macroeconomics to microeconomics. Because why? Because choices of individual agents that are the stuff that's most relevant on the micro level, are also influenced, for instance, by expectations regarding macroeconomic variables or by the economic inequality of the society. So inequality of a society is, of course, a macro property of the society. People act on this basis, so it's the macro level already influences the micro level, and therefore it doesn't really make sense then to ask, can the macro level reduce to the micro level? Because it's already present in there, and then the whole question becomes very fishy and strange. Now, one has to be a little careful here again, because it's not the macro level itself that is involved in the individual's choices, but individual beliefs about it, right? It's not the inequality itself that influences then the micro level, but it's the beliefs about the inequality, right? And the same holds about policy, you know, the policies at the macro level that may influence the micro level. It's not the policies directly, causally influencing it, but it is the beliefs of people, what's happening there. So it's legitimate, even necessary, to include these beliefs on the micro level. Otherwise, the characterization of the processes on the micro level would be incomplete. Right? It's, of course, people do make choices. looking at their surroundings, not only what goods they already have and what their preferences are, but also they anticipate what's going on. Shall I buy the car today? Shall I buy it in a year from now? Oh, car prices will go down. Okay, therefore I wait. And therefore you have ideas about the macro development, but it's all in you. It's all your beliefs, right? It's not the macro level itself. It's the beliefs about the macro level. Incomplete, if you left out these beliefs, then of course, then the reduction is trivially impossible. If you don't tell everything that is necessary on the micro level, then of course you cannot reduce the macro level to the micro level. So you got to, of course, include in the micro level the properties of the entities at the micro level, and these are the subjects that make choices, right? Firms, individuals, and their beliefs, of course, play a role. Whether they include beliefs about the macro level or other beliefs, it's irrelevant. It's their beliefs, and of course, you want to reduce, you've got to take that into account. So this is now, again, by the way, and I must admit that I'm quite surprised that happens so often, because this is now, I think, the third time that we discover that the difference between a certain factor and the belief in the factor is a very important difference, right? We saw that in Horstman's model. And there seems to be some, carelessness perhaps, that people do not distinguish that, but it's very important, in some cases at least, to distinguish the beliefs from the things that are believed in or believed of. So that the beliefs of the actors are about the macro level does not entangle the levels in such a way that the asymmetric separation of the two levels is impossible. Asymmetric, micro is different, first of all, different from, and it determines macro, right? The micro level determines macro, clearly. I mean, there's no degrees of freedom at the macro level, you know, that the aggregated quantities can do anything without micro agents doing anything. But the point that that the agents, the firms, and the individual consumers and so on, that they have ideas about what's going on at the macro level, there's no argument whatsoever against the reduction, because what really happens at the macro level is, in that sense, independent of the micro level. So the levels are well distinguished, so this is just not an argument. All right. An additional note here, even if there was some sort of interaction between the macro and the micro level, that's not really an argument against reduction, because if you look at the successful cases of reduction, say in genetics, for instance, if you look what happened between now, say, 1900 and it started in the 1920s and then going until up to today, in genetics you had classical genetics where you had no idea what a gene is, and it was just a calculating device, and now we know quite a lot about genes. It's DNA and all sort of stuff. And when you look at this discussion between classical genetics and then molecular genetics, there were various interactions, and I show you here. You start with a hypothesis H at the macro level, so you have a macro level, and then you say, oops, it looks like we have a following regularity here, and then you try to understand H from the micro level, and you discover that it needs corrections, resulting in H star. This happens, for instance, thermodynamics, this happened exactly. So you saw that the ideal gas law, you try to derive it, and then you see, oops, the ideal gas law, I get it only under certain very special condition. What happens if I change these conditions a little, and then you get a different law there, gas law, van der Waals equation, or whatever. So that happens. You analyze a system in terms of its parts, and then you discover, oops, what I assumed here at the macro level needs corrections, so I get H star. Then you say, okay, let's now analyze H star anew in the micro level, and then you discover that your micro level theories may need correction. Then you say, oops, I've got to be a little more careful in view of H star, and then you change something at the micro level, and so on and so forth. The point is the fundamental reductionist impulse remains unchanged, namely to understand a system in terms of its parts, period. Right? That remains unchanged, even if the research strategy is such that you sometimes analyze in terms at the macro level, and you analyze stuff there in terms of macro stuff, getting nice equations at the macro level. Then you go down to the micro level, you may change something, then you go back and forth, and therefore you make progress on both levels. So the fact that there is some sort of interaction, and in that sense an entanglement, is not an argument at all against what reduction is all about. Reduction is all about understanding or predicting or deducing the variance of a complex system in terms of its parts. That's the main thing. And that is possible, not possible, whatever. And that's the main question. Okay? And the third anti-reductionist strategy is also an interesting one, and he uses, namely, what he claims, what Hoover claims, there are laws or regularities on the macro level for which a reduction to the micro level is useless. It's another strategy, right? You may say, you don't even engage in the discussion whether it's possible or not. You just say, look, it's useless. It doesn't bring anything. It's scientifically just empty. Here's the example. There he uses a source of inspiration, which is in that particular case a fantastic source. It's a wonderful example. I've been using it for years. Well, that's not a good argument. That's a good example. But anyway, it's a good example. It's by philosopher Hilary Putnam. And I give you the example in a form that's, I think it's his original, basically. It's the square peg and the round hole, okay? I had to look it up. A peg is this thing here. That's called a peg. I hadn't known that word. Anyway, but I knew what a round hole was. So we have a peg and a round hole, and the question is, does this peg go through the round hole? What are the conditions? Well, we've got to introduce the variables here, and there is the side of the square, and there is the diameter of the hole, and what else do we need? Well, and then, oh, look at that again. That took me quite some time to do this little arrow, and then the peg is supposed to go through this hole, okay? And then we can discuss the going through condition, right? Under which conditions does the peg go through the hole? And it's very simple. That's elementary, well, it's not arithmetics, but it's a little more. So it's a times square root of 2 must be smaller or equal to 2r, right? Then the diagonal of the peg must be smaller than. So that's quite clear. Okay. So now imagine now someone says these are macroscopic bodies, right? We got to reduce that. I mean, this is all made of molecules, right? So we got to reduce that and understand the whole situation in terms of molecules. Now, if you try to reduce to the micro level, you must uncover the molecular basis of the solidity of the peg and of the hole, because the whole thing depends, of course, on the solidity of that stuff. If it was a rubber or chewing gum or whatever, then it's different. So it depends on the solidity. Now, the point is, if you look at the solidity of macroscopic bodies, they are very, very, very differently realized. So the molecular realization of solidity is very different, for instance, for wood, for steel, for glass, for ceramics, and so on. There are worlds in between concerning physics. The difference between, for instance, glass and stone, for instance. I mean, glass is a liquid, right? And stones are not liquid. So, and ceramics is something different again, and wood is something different again. So there are many, 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 many different ways how in molecular terms, solidity is realized. But the point is, this is obviously irrelevant here, right? The particular realization of solidity for this particular case is irrelevant. You just got to have solidity. You do not learn anything by going concerning this general situation, the going through condition. In that particular case, you do not learn anything if you go down to the molecular level. It just doesn't make any sense. So you would not gain nothing if you have a science of peg and holes or something analogous to that, and their going through condition would gain nothing from being reduced to the micro level. Right? You just don't get anything. What you can learn is how many different forms of solidity it gives concerning the micro level. But concerning the peg-hole science, you don't learn anything, because what you need there is geometry and solidity. That's it, right? So this science of peg and holes lives entirely from geometry and the macroscopic property of solidity. And that is exactly what Hoover has in mind with his physics of simple machines. This is, so to speak, the simplest machine of all simple machines, this peg and hole stuff, right? And there you see, this is his intuition there. There you see, yes, going down to the micro level is just useless for these cases. Due to the macroscopic property of solidity, the causal relations are obvious under which conditions that thing goes through. Now, the interesting question is now, that's in principle a good strategy. If you can show that, in many cases it works. Well, if you look at, for instance, thermodynamics is very similar in physics, because in thermodynamics, you are, for many things, you are independent of the special properties of the sort of matter you are investigating. So certain physical laws are independent of the sort of matter you are having, and therefore you can do what's called phenomenological thermodynamics, where you speak about temperature and volume, entropy and that stuff, free energy, and there you don't need, indeed, the properties of matter. However, people have tried to reduce it then to statistical mechanics and found interesting stuff, but the question is here whether macroeconomics is really similar to this pack and hold case. And this is the question one has to ask here. Are there robust macroeconomic causal laws with known intelligible limitations such that a search for microfoundations of those laws would obviously be useless, like this going through condition? Is that really the case? Well, I cannot judge that, quite honestly. I can read a little. My impression isn't the core of the Lucas critique that an investigation into the possible limitations of some macroeconomic relation necessarily also involves the micro level. I think this is how I understand the Lucas critique, and from what I hear or read is that the Lucas critique has been taken very, very, very seriously in economics for that reason. And you take that only seriously if you don't have the trust, the confidence that there are some macroeconomic relations which are just as solid as this pack-hole situation. And this is at least suggested by parallels to other sciences, for biology, chemistry, physics, where one always tries to analyze and understand upper-level regularities in terms of lower-level mechanisms, because it's just interesting, right? To understand how is this seemingly material independent relation at the macro level, how does it come about? And you cannot learn something. And this is what typically happened. It may be that for decades, even for centuries, people do not ask the question, go down to the micro level. But sooner or later, people do go down to the micro level, and then quite often it's interesting. So I don't really know whether that what Hoover says here is really persuasive. And those macro relations that I've seen in macroeconomics are not of the kind that you say they are so stable, we know they function so wonderfully. I mean, if you take Okun's law, I mean, this is so statistical, and you say, oh, come on. I think it's useful to better understand from the micro level. But the point is, in principle, this is a good argument. In principle, the argument that you say we have regularities at the macro level that are independent of the properties of the micro level, and therefore they enjoy a certain autonomy that we can discuss them apart from the micro level. The point simply is this the case of macroeconomics? And I don't know. If I had to bet, I would say, I guess not. But this is a normal situation, that the concepts you use to describe the macro level are inapplicable to the micro level. Right? This is the criticism of the representative agent models, right? Where you represent the whole economy as a representative agent, and what you do there is you skip, indeed, the differences between the conceptual vocabulary that you use to describe the micro level from the conceptual vocabulary that you use at the macro level. They look completely different, right? For instance, this is one of these examples that Ernst Mayr brought up, when he said when you have the behavior of organisms when they have their sexually motivated dances around each other, and then he says if you analyze that in terms of the energy consumption of the simple bodies, you never get to the meaning of the biological meaning of what these movements of the individuals do. Yes, right, but nobody said that this is the way how to reduce it. That's, of course, you may make a caricature of what a good reduction is, and then you say, look how idiotic it is. No, of course. And of course you do not find the concept of sexual attraction in molecular biology. Of course it isn't there. That's a property of organism, that they develop something like sexual attraction, and that's the same. You develop something like a general price level is something that really belongs, or inflation, that really or inequality that really belongs to a society or economy as a whole. So this is why reduction is interesting. The question, namely, that something looks so different at the macro level, and then you try to break it down to the micro level and understand it, right? Like temperature. I mean, temperature is so, molecules don't have a temperature. Not, in no sense. They have energy and velocity and mass and whatnot, but they have no temperature. Temperature is a phenomenon of a collection of molecules. And that's the same in principle. Inflation, for instance. I mean, inflation is nothing that a singular agent, firm, whatever on the micro level has. It's not a property it's a property of an economy given certain parameters, right? So the difference, the conceptual difference between the macro level and the micro level is what makes reduction so interesting, right? There you say, oh, we have very funny properties here on the macro level. Is it possible to understand them by going down to the micro level? That's the challenge, right? And therefore, this difference, this conceptual difference is never an argument against the possibility of reduction, because it's very deceptive, as we've seen too often. Right? Therefore, I never believe an argument, even if I don't know anything about the area, if someone says, look, they are so different conceptually, I say, so what? That's not an argument, right? Had too many cases in which this conceptual difference had been bridged by a series of small steps. And it's amazing when you make enough steps, how you can then transform or break down a phenomenon of a very, very complex kind, then in a series of steps to something which is then very simple, concerning very simple components. So one has to be extremely careful here and don't trust your intuitions. It doesn't work.